Hey guys, Mr. Math Whiz here. Just wanted to give you a quick summary of today's lesson. Today's lesson was kind of a big lesson, but that's because it was actually 3 mini lessons in one. So I want to make sure you guys caught it because I know there was a lot of stuff and I went kind of quickly with it. So the 3 things that we talked about today, we talked about how to divide fractions, we talked about percent error, and then we talked about using substitution to evaluate expressions. So those were the 3 big ideas, not really connected. But all those ideas connect to things that we've already done in this unit. Because this unit's all about multiplying and dividing positives and negatives, right? And we taught that basically within the first 1 or 2 lessons, we had all those rules covered. So the end of the unit is using that information in the real world and in other things. So how can we use what we learned about adding and subtracting positives and negatives and multiplying and dividing positive and negatives? How do we use that in other parts of the world, in other parts of mathematics? That's really what today's lesson was about. So we're going to talk about it real quick. This video might be a little bit longer than some of my other ones. I apologize for that. Also, I may pause you all at some point because I got food in the oven, hence my fancy apron. I'm cooking dinner, multitasking. So if I pause, I'll be right back because that just means I got to move some stuff around. All right, so here we go. So the first thing we talked about was dividing fractions. So the examples that the book used talked about cutting some wood and some things like that. We'll do one similar. I'll use a different problem though. So let's say that you have a project going on and you need a bunch of pieces of wood that are 2.5 feet wide, or I'm sorry, 2.5 feet long, right? You go to the lumber yard, you go and figure out what they have, and they have slats that are 12 feet long. And so you're wondering, well, how many of those could I get? So from what you guys know about division in the past, you know if it was 12 divided by 2, that'd be easy, right? If you had 12 feet and you're dividing by 2, oh, this thing's shaking a little bit. Let me see, 12 feet, and you're dividing by 2, that would give you 6 feet, right? Easy peasy, summer breezy. So that's not the case though. Now we got fractions. So let me make my pen size a little bit bigger so you guys can see it. All right, so this time we've got fractions. So this time we're going to take that 12, move myself. All right, this time I'm going to take that 12.5. Oh, I'm saying it wrong already. It wasn't 12.5, it was 12 foot. So we had a 12-foot piece of lumber, and we want to know how many times 2.5 can come out of it. So 12 divided by 2.5. That's what we're trying to do. So to do that, first we're going to turn the 2.5 into an improper fraction. So 2 times 2 is 4, 4 and 1 is 5. So you guys should remember how to do that. The 2.5 can be written as 5 over 2, okay? If you're not sure how I did that, please ask me in class or before class and we can talk about it one-on-one. Oh, my video went away. I thought it'd be better if I had the video up. Oh, dang it. Oh, well. Anyways. We'll do it over this way. So 2.5 becomes 5.5. So now that means we're having 12 divided by 5.5. Well, to divide a fraction, we're going to use the keep, change, flip. So we're keeping the 12, we're changing the division sign to a multiplication sign, and we're flipping the 5 over 2 to become 2 over 5. That's what we call its reciprocal. So we don't like dividing by fractions. It's much easier to do multiplying. So we're using the reciprocal, so now it's 12 times 2 over 5. So to do this, all we're doing is we're multiplying the 12 and the 2, which is going to give us 24. And now we have 24 over 5. So that's our answer as far as what you get if you divide 12.5 by 2.5. But that doesn't really tell us what we're looking for. What we're looking for is how many slats will we get out of it, right? How many 2.5-foot pieces are we going to get out of this board? So we still have a fraction. Let's go ahead and turn it back into a mixed number, and that should help us. So how many times does 5 go into 24? Basically, we're doing 24 divided by 5 now, right? Because 24 over 5 is the same thing as 24 divided by 5. So 5 goes into 2 no times. You can't take 5 out of 2. 5 goes into 24 4 times. Gives us that nice 20 there. Leaves us those 4 left over. So now we know that you have 4, 24 over 5 is 4 with a remainder of 4, basically. So 4 and 4/5. All right? So how many 2.5-foot slats were we able to get out of a 12-foot board? Well, we were able to get 4 of them, and we had a little bit left over. So our answer to that question was 4 slats. Now, if it asked us how much did you get, how much would be left over, well, then we just have to figure out what we took out. So if we had 4 slats that were 2.5 feet wide, how much is that? So 4 times 2.5. So now we're multiplying the fraction. So that becomes 4 times 5 over 2, right? Which is 20 over 2, which is 10. So those 4 slats took up 10 feet. Our original board was 12 feet. So if I want to know how much was left over, I got to do 12 minus 10, and that gives me 2 feet left over. Does that make sense, guys? So we divided it out. We divided out the 12. We divided out the 12 by the 2.5, which gave us 4 4/5, which meant that we had 4 whole slats, and we had some left over. And we figured out the leftover bits by taking the 4 times the 2.5, which gave us 10. And if we used 10 feet, and there was originally 12 feet, then that's going to give us 2 feet. All right, so now that was a lot of stuff. That's basically the premise of, let me close this. That's basically the first part of today's lesson. Like I said, today's lesson was a 2-part lesson. There we go. Today's lesson was a 2-part lesson. That was basically the first part. So the second part has to deal with what we called percent error. So what percent error is exactly what it sounds like. It's the percentage that you were wrong about something. So when you're doing percent error, you have percent error. And this should be something you've wrote on your note sheet. Percent error is found by taking the actual value minus the estimated value and dividing that by the actual value. All right, so the actual minus the estimate divided by the actual. In the real world, you see percent error all the time. You see it in math, you see it in statistics, you see it everywhere. So this is what it means. All right, you take your actual minus your estimate divided by your actual. So if let's say I was one of you guys, right? And I made an estimate. My parents asked me, hey, how good do you think you're going to do on that test? And I tell them, I think I'm going to get an 85. So that's my estimate, right? And then I get the test and it turns out to be a 70. Well, how far off was my estimate? Let's see. If my actual grade was a 70 minus 85, which was my estimate, and then I divide it by the actual, which was 70 again. Notice that number is used twice, okay? The actual is used twice in this equation. Once for subtraction and once for division. So if I'm doing this now, oh, that's my timer. Gotta pause, move some food around. It's not gonna let me pause. Dang it. All right, I'll get to that food in a second. Let me finish this up and then I'll pause. All right, 70 minus 85 gives you, well, if you know your subtraction rules, that we could basically treat this like negative 85 and positive 70, which means we're treating it like subtraction. 85 minus 70 is 15. 85 minus 70 is 15, but this is going to be a negative 85. I'm sorry. I meant negative 15. This is going to be negative 15 because the 85 was the larger number. Remember when we were adding and subtracting, we said the larger value is the one that's going to have the sign that our answer is. So since the 85 is the negative part of the equation, we're going to give the answer negative 15. So we have negative 15 over 70 now. So I want to turn that into a percentage. Before I can do that, I want to turn it into a decimal. So I'm taking negative 15, I'm dividing it by 70. Notice there's a lot of steps in this work, guys, but nothing's in here is stuff that we haven't already done. You just need to understand the individual steps. So 70 goes into 15 how many times? Well, 15 is too small. It doesn't go in there at all. So now I got to do some long division. All right, so we said it went 0 times, so I got 15. Bring down my 0. All right, so how many times does 70 go into 150? I believe it goes in twice. Let's see. So 2 times 70 would give me 140, which leaves me with 10. So yeah, that was a good, because you want to get as close to 70 as you can without getting over. So I'm going to add another 0, bring that down. How many times does 70 go into 100? Well, it looks like 1. So that gives me 70. I subtract that. That's going to leave me with 30. Do my 0, bring it down. How many times does 70 go into 30? 5 is going to be too many, because 5 times 70 is 350. So I'm going to go with 4. Let's see if 4 works. 4 will be 280. That gives me a 20. Yeah, that works. All right. So I'm going to say, I can keep going, but I'm going to say that my answer is approximately 0.214. But I'm looking for a percentage, because they're calling this percentage error. So to do a percentage, I have to move that decimal point 2 places, right? So my percentage is approximately 21.4%. You guys with me? Or I could just say 21%. So that's my percent error for this problem. So some big things I want you to catch with percent error. 2 big ideas. Let me switch back to the camera so you guys can see my face while I'm doing this here. So 2 big ideas when we're talking about percent error. You have positive percent error and negative percent error. Ooh, did I forget to put the negative sign on that? I think I forgot to put the negative sign on that. My bad. Math mistakes happen. So in that problem, we had negative 15. We had negative 15 over 70, right? So what happens when you have a negative divided by a positive? It becomes a negative. I forgot to do that. So that percentage we had, that 20%, is actually negative, what was it, 21? Was it 21%? Negative 21.4? I think so. I already erased it. Sorry, guys. But it should have been a negative percentage. So here's some big ideas with percent error. You're going to have negative percents and you're going to have positive percents. A negative percent, when you're talking about percent error, negative percent means your estimate was too high. Or it could mean, in other words, the actual value was lower than you were guessing, okay? Your actual value was less than you expected. So in this case, if you were expecting an 85 and you got a 70, your actual value was less than what you were expecting, and so you have a negative percent error, okay? If you get a positive percent error, then that means the actual value was greater. The actual was greater. Or you could say your estimate was too low, right? So this one up here, we said that the actual was lower. All right, so that's one thing you need to remember about percent error. Second thing you need to remember about percent error is that, boom, boom, the smaller the percent error, the smaller the percent error, the more accurate, sorry for the sloppy handwriting, the more accurate your estimate was. So in other words, if you have 2 weathermen and one weatherman has percent error of 35%, but another weatherman has a percent error of only 10%, which one would you want to be your weatherman? The guy with 10%, because his error is smaller, which means that his estimating is more accurate, which means that he will be better at telling you the weather. So your smaller your percent error, the more accurate you are. Good stuff to know. I'm going to pause it now so I can take care of my food, and I'll be right back with the third part. All right, I'm back. Last thing we wanted to talk about was evaluating expressions. All right, so evaluating expressions. By the way, if you're worried about my food, it needs to cook a little bit longer. Still raw. That's why I use food thermometers. All right, so I am going to talk about evaluating expressions. So if you have a question on a test or a study guide or quiz or whatever, also you'll see these on standard tests like the benchmarks. So if you ever have a question that says evaluate the expression, and then it gives you an expression. So an expression is basically just a math problem, right? So if it gives you an expression, it says evaluate the expression 2.5. Oh, we just use a 2.5. Should I really use that again? Let's change it. Let me give you something else. Let's do 12.5. Haha. All right, so you get an expression, 12.5 minus 5x. All right, so that's your expression. And so it says evaluate the expression, blah, and it says when x is, and they give you a value for x. I'm going to use negative 1/2. I'm doing a lot of 1/2. Sorry guys, just easy math. For these videos, I try to keep it easy. In your workbook and in your study guides, they're going to be harder, okay? But I want to keep them simple for the video. All right, so if this is what the expression says, all this means is that you're taking this value, because this value equals x, right? These things mean the same thing. So you're taking that value and you're going to substitute it. We call this substitution for the x, okay? So that means you're going to have, I'll keep the purple. I like the purple. So that means, oh, I shouldn't cover the camera. That means you're going to have, oh, that works. 12.5 minus 5, and the x is being replaced by 1/2. So when the x is being replaced by 1/2, it does not mean 5.5, because the x is actually being multiplied by the 5. So this means that negative 5 is now being multiplied by, oh, it was negative, I'm sorry, by negative 1/2, okay? So now to solve this, we got to solve each part. If you remember your PEMDAS and all that, you would do whatever's inside the parentheses first. So if you remember that, I'm not a big fan of PEMDAS, but some people love it. Basically, it means you do the parentheses first, then you do any exponents, multiplication or division, addition or subtraction. So everything in the parentheses has already been solved, so now we're going to do our multiplication. That 5 is being multiplied by our negative 1/2. So the next step is we're going to have the 12.5 still, nothing changed there. And we're subtracting, what is 5 times negative 1/2? Well, we have a negative and we have a positive. So our answer is going to be negative, right? Because if you multiply negative and positive, you're going to have a negative. So I got negative 5 times 1/2. Well, if you multiply that, you're just doing 5 times the 1, which is 5, and then the 2 remains the same. So now we have 12.5 minus negative 5/2, or 5/2, okay? So we're subtracting a negative. If you remember your addition and subtraction rules, you should know that subtracting a negative is the same thing as adding the positive. So this can just become plus 5/2. So now we have 12.5 plus 5/2. So the next step is we're going to have to turn that 12.5 into a mixed number. So, I'm sorry, an improper fraction. I always say that. Improper fraction. So 2 times 12 is 24, and the 1 becomes 25/2. So we have 25/2 plus 5/2. Remember, whenever we add or subtract fractions, the denominator has to be the same. In this case, it already is, so maybe I made that too simple for you all. If the denominator was not the same, we would have to multiply the top and the bottom of the fractions until they were, okay? We did some examples of that in an earlier lesson when we practiced adding and subtracting. This would have been last unit when we talked about adding and subtracting fractions. So if you need to look back at lessons from last unit, feel free to do so. So the denominators are the same. We're going to keep it as a 2. So we just add what's on top. 25 plus 5 gives us 30. So 30/2 is our answer, which basically just means 30 divided by 2, which you guys should know is 15. So the answer to this problem is 15, okay? So when it says evaluate the expression, all it really means is you're substituting whatever that value was that x equaled, you substitute that number for x. And then you solve like normal, going through whatever steps you need to go through, okay? In the study guide that you guys are going to get from me, there is a section that asks you what the name of each step is. I'm not going to be judging you on that. I'm not going to have the names in the test. So I'm not really worried about if you remember what each little step is called, but it is important that you understand how to do every step. All right, that's my video. I'm going to stop this now because I think my food's done. I better check on it. You guys have a great rest of your day, and I hope you're having a lot of fun and enjoying this unit. All right, bye.